So here is a video of a rotating globe. And as you'll notice here, Antarctica there at the bottom of it always has the sun. We can't have a 24-hour sun on the flat Earth model, and we must have a 24-hour sun in the globe model. And you can see because of the tilt of the globe that the bottom there, which is Antarctica, which is a little bit hard to see, would never be in the darkness.
That was Will Duffy, the creator of the final experiment, and he was just explaining how Antarctica can experience a 24-hour sun in December. If you've still not heard about the final experiment, then I'll put some links in the description below, but essentially, Will is funding an expedition to the continent where flat and globe earthers alike can witness and record what the sun does, and hopefully falsify one of their models in the process. So in this video, I'll be constructing some geometry that will help us visualize what's going on for the globe model. Let's start off from scratch with a point at the origin for the sun. Next up are the radius values for the orbit and for the Earth. This is the orbital path for the Earth, and I've kept things simple by making it a circle. Directly under that circle is another just like it but in black. It serves no purpose other than to give the orbital path a cool shadowy effect when viewed from underneath. Next is a center point for the Earth. We can drag this around, or we can animate it. S and C are two values that will feature in the creation of the polar circles, the tropics, and they'll also be used to give the Earth its tilt to the ecliptic. U is a vector that points from the Sun to the Earth's middle, and V is a vector for the Earth's tilt. I use these to give direction to circles and to ensure proper point placement. For example, this is going to be the terminator line. It's a circle centered on E with radius R, but as with all things in 3D, you need a third parameter that gives direction. That's this vector. T and B are the top and bottom of the terminator, and I use these points to create night and day. Here I've used some vector addition to make the north and the south poles, and this line makes the equator. The other latitude circles look a little bit more complicated to make, but not if you remember what each parameter in the circle function represents. E plus RSV is the center point of the circle, RC is the radius, and V is the direction or orientation in 3D space. And you'll notice I didn't have to use 66.5 degrees anywhere to create the polar circles. Leave me a comment down below if you know why. Next up is our subsolar point, or the GP for the Sun, and that's this line. And notice how it appears to move between the tropics as we move the Earth around the orbit. This tiny little point here on the equator I've labelled Q, and I've used this to create some meridian lines, and I can also use this point as well. I can rotate it 80 degrees in order to create Union Glacier. That's this red point here. These 4 points help us to figure out where we are in the orbit. And this information text box tells us a couple of things. This arrow will point up if the Sun is visible from Union Glacier, and it will point down if it's below the horizon, while this angle here tells us how high the Sun is in the sky. And lastly, to finalise the construction, we have an animate checkbox so we can get things moving. So let's start off in March, when we have equal day and equal night. The Sun's GP is on its way to Cancer. The Arctic Circle is now almost totally in daylight, 24 hours a day, and we've lost the Sun down in Antarctica. I'll just stop it here. So now we have no sun down there, cold and miserable, and the Arctic Circle is enjoying all the light. Let's continue. So the GP of the sun is on its way back down towards the equator. Still got no light down here, but that will change shortly. This arrow should start pointing up periodically as this red dot passes the terminator line, and they're getting happier again. We'll stop it there, and the sun is now due north from their position. It's 10 degrees high in the sky. Let's make our way round to December. The GP is now on its way to Capricorn. It goes without saying that the speeds I've picked for the orbit and for the rotation, they're just random. It's not really to scale, but saying that, these angles will be correct. So this is the interesting bit now. Stop it there. So the Arctic Circle, 24-hour night, but down here in Antarctica is 24-hour sunlight. At the moment the sun is high in the sky at 33.5 degrees, but if I was to click on this dot here, this one that's labelled Q, that will rotate the Earth by 12 hours, and now we can see that the campsite is now having to look due south to see the sun, and it's a bit lower in the sky, 13.5 degrees, but they're getting sun all day long, 24 hours. And we'll just complete the circuit. We'll get back to March. The sun is on its way back towards the equator. Everybody up north are singing and dancing that the sun's on its way back again. And very soon Antarctica will start getting nighttime again, and that completes one orbit. So that's pretty much it for this video. If you like this one, then do hit the thumbs up for me, and of course I'll leave a download link in the description. So thanks very much for watching, and I'll catch you later.